Okay, recording has started and welcome everyone. It's a bit weird. Please note if you haven't gotten used to the quadrimester already, we are going to be starting at 8:45. We are going to go up to 10, and you're supposed to have a 30-minute break. But I'm feeling, if you have to go to the washroom, you probably can go while we're having a lesson and whatnot, anyways. So let's try this just for this week. And then if it goes well, then we can continue this while we meet face to face. 10:15 to 11:30, right? And then from 11:30 to, I believe, 12:30, everyone's supposed to be doing their own work, or they're supposed to be live syncing. There's supposed to be a lot of weird stuff happening. I am going to be available in this chat. And of course, next week on, I am going to be available in class until 12:30 for anyone who wants to ask extra questions. So if you go to university, this is exactly what happens. Professors will literally just sit in their office for an hour, wait for people to come visit them and ask questions about the material. In the same way, this is going to be sort of a Q&A or a tutorial or extra help, whatever you want to call it. Okay. Welcome, Will. I'm going to have to update your attendance. Quick sec. It's going to register late, which is fine. Do your best to get here on time, just because, sometimes there'll be valuable information. Let's see. So yeah, if you don't want to stay for the Q&A or tutorial extra help, that's actually okay for you, because you're responsible for self-directed studying. Okay, how you want to use that time, I'm not going to hold it against you. If you want to take the break because having 2 straight hours of math or 2.5 hours of math is a little rough, I don't think anyone's going to hold that against you. But know that that is the prime time for you to sort of stop by. If we're doing it online, I will, share screen like this and help you out with whatever questions you have. If you're in person, just stay while everyone sort of goes. And then from there, I believe it's just lunchtime and whatever. And then from 2 o'clock to 3:15 is your other course. Now, of course, for the people who are if you're in the flip cohort, you don't see me in the morning, and you'll see me at 2 o'clock to 3:15 just for 1 hour. Well, 1 hour 15. Okay. Any questions? No, I'm gonna take it as silence because we don't have that much time to sort of kill. If you do have something to say, please don't be shy. Just unmute and ask if they have a question. Be like, hey, go for it. Okay, I'm not gonna yell at you for raising your hands or anything like that. Let's be honest, this is digital. Being the first class, I would also spend some time getting to know each other. I often talk about my expectations, like how you're going to go to the washroom, what I expect from you in terms of hard work, your math skills. Do you have to be a pro? No, absolutely. But are you allowed to give up? Absolutely not. Things like that. And also just personally get to know each other by playing like a get to know each other game, like Two Truth, One Lie. That's my favorite. I give you like 5 truth and 1 lie of myself, just so that you feel a little bit more comfortable, because it's math class. It's not like it's art where you can express yourself. It's not like it's gym where you can just, let your body go, right? You have to really hunker down and focus. So it's not easy. That was 15 minutes already. I'm going to give you about 5 minutes. Please make sure your handouts are ready. And at the same time, I'm going to have people have an opportunity to sort of, develop a sense of a classroom. Forget 5 minutes. I'm going to give you 30 seconds. Someone told me long ago that if you really wanted to know someone, you should know what they dislike. Um, And I think that makes sense because if you think about, in cartoons or in movies, our enemies, they know so much about each other, right? Like superheroes and supervillains, that if it was a parallel universe, they'd be best friends because they know so much about each other. And so I'll give you 30 seconds. And then we're going to go down the list, at least my list of who's in my screen right now. I'm going to call you out. Just be like, hi, this is my name. Whether your birthday has passed or not, which is sort of funny because it's February, and what you dislike the most at your point in life right now. Okay? 30 seconds. Go. Think about it. Twenty seconds. Ten seconds. All right. I'm just gonna go left and right on my list or on my screen. And so if I call your name, just unmute and go for it. First up, Monica. Let's hear from you.
Am I supposed to say my birthday too? Do I say my birthday?
Not the date in case you feel uncomfortable, but just you know what? I'm stupid. You don't have to say anything about your birthday. Just name
No,
and
I
what
can.
you hate most
I don't
about
mind. Okay, my birthday is May 5th, and I hate taking naps, and I hate olives.
You don't like naps?
No, I hate them.
That's rad. It's crazy for me because I dream about sleep because I have a 4-month-old as well. I have 2 kids now, and so I'm dying, if you can't tell. Anyways, thank you so much, Monica. Next person is Hazel.
Hi, I'm Hazel. My birthday is May 11th, and I hate COVID.
There's so much weight behind hating COVID. Thank you, Hazel. Claire.
My name is Claire. My birthday is May 23rd.
Oh my goodness, so many Mays.
I hate how cold it is right now.
Fair. Thank you, Claire. Maddie?
My name's Maddie. My birthday is January 26th, and I really hate tomatoes.
Tomatoes?
Yeah.
What is wrong with you people? First olives, naps, and now I'm good. Maddie, you have reached your sweet 16, so congratulations. Must have been a big deal. I don't know how you might have celebrated it, but yeah. Next up, Abby.
Yeah, I'm Abigail. I prefer to be called Abby. My birthday is May 28th. And I hate black licorice.
Okay, I get that. I'm not sure how many other people get it, but we have 4 Mays out of 5 so far, I believe. And Abigail, did you say you don't like going by Abby?
Oh, I do. I
Okay,
prefer being called Abby.
got it. Josh Hardy.
My name's Josh. My birthday's in April, and I dislike dark chocolate.
Okay, can I say something? You know what? It's a good thing. We are an eccentric ragtag group of weirdos. Okay. People don't like tomatoes. People don't like olives. Now dark chocolate. What? No. Okay. Dark chocolate is. Let's move on. Marin.
Hi, I'm Marin. And my birthday is October 26th. And I don't like seafood.
Thank you, Marin. Aiden, you're next. Aiden. Are you
Hi, my
sleeping?
name is Aiden.
Hi. Yes.
I'm born in August 8th, and I don't like school.
That puts me in a hard spot. I hope I can make your experience a little less dreadful. Jordan. Jordan Stein.
Yeah, sorry. I'm Jordan. My birthday's November 1st. And I don't like COVID.
That's fair. That's
Yeah.
very understandable. Thank you, Jordan. Sydney.
Sorry, which one?
Oh, sorry, Sydney Kendall.
My name's Sydney. My birthday's on Thursday,
Oh.
and and I don't really like milk.
Okay, that's interesting. Thank you very much. Let's see who's next. Daniel Rain.
Hi, my name's Daniel. I was born November 11th, and I don't like Tom Brady.
Interesting. All right. Thank you very much. James Carthy.
Hello, my name's James. My birthday is October 20th, and I do not like the weather right now.
Fair. Yeah, I don't think a lot of people do. Thank you very much. Dahlia?
Hi, my name's Dahlia. My birthday is May 7th, and I dislike not being able to choose what I do with my time.
Fair. It's, I don't know. Let's move on. I know what you're saying. Lynn?
Hi, my name is Ling, and my birthday is August 6th, and I don't like coffee.
Fair. Felix? Felix? One more?
Yep. Spacebar has been working for some reason. My name is Felix. I was born September 14th, and I don't like people who don't think they need to care about other people.
That got heavy real fast, but cheers. That's fair. Very fair. Kennedy?
Hi, my name is Kennedy. My birthday is July 16th, and I don't like baths. That sounds weird. Like I don't love it. I love showers, but just like a relaxing bath is not appealing to me.
Okay. Yes. You got to give us a, yeah. You got to give us that disclaimer first. Otherwise, people will get the wrong message. So funny. Sydney Farron? Roller coasters. My 2-year-old will not be your friend. She's hurting herself just to get a thrill, but that's fair. January's. Oh, you also reached your Sweet 16. Congratulations. Hope you get to enjoy some of it, and that the vaccine rolls out fast so you can hang out with your friends a little bit and celebrate. Josh K.
Hi, I'm Josh. My birthday is March 2nd, and I dislike not being able to play sports.
Fair. So do I. I think I gained 10 pounds since COVID started. Ivan.
My name is Ivan, and my birthday is January 23rd. One thing I hate is winter.
It's a tough time for you then. Congratulations on your birthday as well. Hope you get a chance to enjoy. You're only 16 months. Helen, are you with us? Oh, is it 17? Oh, that's my bad. My bad. No one corrected me. Like I was making such a fool of myself. Helen, I think your mic is off, but that's okay. If you want to type it in, I'll come back to you after. No, Helen, we can't hear you. It could be a tech issue. It could be just the computer chooses to pick up sound through your through a mic or something other than your laptop or whatnot. I'm not sure. Just like waking up in the mornings. Thank you for being here then. I appreciate you even more. Let's move on. Aaron Curry.
Hi, my name's Erin. My birthday is February 10th, and I don't like tomatoes.
Best friends with Maddie. Excellent, you weirdos. Thank you for sharing. Alex.
My name is Alex. My birthday is October 1st, and I don't like asparagus.
Yo, sharing too much information, but asparagus makes your pee smell so bad. I'm not gonna lie. It's not the best. Not the best vegetable. Jose, are you with us?
Yeah, I'm here.
Yeah. Could you share your birthday and what you dislike the most right now in your life?
So my birthday seems most of people don't realize, but it's September 15th.
Mm-hmm.
And my I don't know, 2 or 3 most hateful thing is the dark chocolate, the roller coaster, and the cops who angry with a drifting car.
Interesting. I love this class. It's full of weirdos. Thank you very much, Jose. Will, you with us?
Yeah, I'm here. My name's William Afwork, and my birthday was August 2nd, and I hate spiders.
That's fair. Yeah. Did I get everyone? I think I did. Everyone, thank you so much for participating. It's helpful. Not only that, it at least puts a person behind the screen. I think it's really important that, especially in grade 11 math, that you don't do it alone. Let me give you an example. I didn't learn this when I was a kid or even in high school because, truth be told, I was pretty good at school. Like I was whipped to shape as a kid. I memorized my multiplication tables when I was grade 2. My dad's scary. A whole bunch of different things. And truth be told, my math wasn't that great. I was subpar in grade 6 when I thought I was amazing. And long story short, I busted my butt and surprise, suddenly I'm teaching math. But because I was trying to be so self-sufficient, what I didn't realize when I got to university was you need to work with people. If any of you are interested in engineering, you will find that just about every single thing you do for marks in university as an engineering program student is group work. Why? No one does any kind of engineering in the real world by themselves. They are always working with people. Everyone has a different part because they specialize in different things, and you're putting it together to create something new that will help the entire world. That's an engineer, right? So you need the skills to work with people. And if you don't have the ability to, one, be humble and ask for help, or number 2, have leadership and help others, you're not going to get anywhere in life. And so I hope that as time goes on, although this class is split in half, you have cohort 1 and 2, you'll be able to connect with people next to you and, for the lack of a better way of saying this, suffer together. That's my goal for us during this quad. And I hope that everyone at the end of the line will be successful. Okay? Let's get to it. That's 30 minutes well spent, in my opinion. I'd like everyone to open up their grade 10 prerequisite sheet. It looks something like this. I uploaded this a little earlier in hopes that people will get a chance to look and try it and see how much of this is really easy, like you could do it in 10 seconds flat, and how much of this you really need some help in. The reason I give you this is because the most important part at the end with factoring, right here, you're going to need to know this or brush up on this real fast. So I'm going to spend most of my time up until 10 o'clock on this. How you spend your break is up to you, but it's gonna be fast and furious. Grade 11 math, there's really no time to stop and sort of, mope around, okay? And you can't fake being okay until you realize you're not okay with math. You have to make moves. You have to ask questions. You can't let up, especially because this is a quadmester. You just got to keep going, keep going, keep going. It sucks. Cry about it. That's okay. I cried about it too. If it's confusing, ask questions, reach out, ask for help, work with people next to you. People next to you don't get it either, reach out to me, email me, write something on our Google Classroom. I will respond. When COVID first started last year in March, the only way I can actually create extra help was basically getting people to either email me or post something on our Google Classroom. And I would respond by creating a video of me doing the answers and then posting it on YouTube or posting it on our Google Classroom so they can use it as reference. That's how serious you need to be for this quad, okay? I might have scared you a little bit, but I want you to be in the right mindset, knowing that, oh, I'm not just gonna drag my feet, hope I get a 50 and move on. Like, it's not easy. And my hope is that everyone works really hard to get through the end. Even if it's not a great mark, it really depends on how well you focus. I'm not asking everyone to get 90s here. It'll be great, but even if you get a 50, that is an accomplishment if you have not given up. The only thing I don't want is like people getting zeros, literally. Speaking of which, factoring, grade 12 factoring. A 5-mark quiz with unlimited attempts and unlimited time is already live. Remember, all my online quizzes are unlimited attempts. The whole point of that is to give you a little bit of marks, but mostly for you to keep trying until you get it right. I need you to practice. So as motivators, here's 5 free marks. Keep practicing until you can do it without guessing and checking. They're all multiple choice. Hope you're on board with me. Let's get started. Grade 10 review. Normally I would ask people to give me their input. For this week, you're just gonna have to bear with me and I'm just gonna talk. Label the following, whether it's a graph or an equation, as linear, quadratic, or neither. I'm just gonna choose random people that are on my list right now. Ask if they know it. If not, just pass, okay? Ivan, you're first on my list as I'm sharing my screen. Can you tell me what this is and give me a reason? No? Moving on. Aaron?
Linear.
Why do you say that? It's correct. Give me a reason why. Aaron?
Oh, because it's y equals mx plus b. Sorry.
Oh, right on. So Aaron is like, hey, this is very much similar to what we learned in grade 9 and grade 10. This is supposed to be a straight line. I learned that. That's fine. That may not come in handy for something like this. So I'm going to use this as a argument for this one. So this doesn't look like y equals mx plus b. Alex Davis, sorry, Alex, sorry. What do you say this is?
I'm not sure.
Not sure. That's okay. Jose?
Oh, I'm here.
Yep. What would you say this letter C? What would you say this is? Linear, quadratic, or neither? That's okay. No worry about it. Pass it. Will?
Oh, wait, I get it.
Okay,
Wait,
go ahead,
linear?
Jose. Sorry, Will.
Wait,
It is
linear,
linear.
is it correct? Linear.
Why? What's your reasoning?
And this is actually same as like mx plus b. And if I put some for y to right side,
Oh, I
actually
see.
it's a different side, but 20 to left side, but turn into a minus 20. That's
Right.
gonna be a 4y equal 2x minus 20.
Good, good.
And if I divide by 2.
Yeah, I'm gonna cut you off there. You're right. This is a rearranged version of y equals mx plus b. I'm actually looking for another answer here, and that will help us with the next one. If you take a look at the x, the order of the exponent for the x for letter A and x for letter C is x to the power of 1. There is no exponent. It is not x to the power of 2, it is not x to the power of 3, so on and so forth. The exponent will show you a lot or tell you a lot about the equation. So with that said, Will, I'm going to ask you to jump to this. Using that argument, what do you think this is going to be?
I think that's a quadratic.
Absolutely. And the main argument for you?
I don't know.
Okay, I'm going to ask you to take a look at the exponent one more time. The largest exponent in this equation is a power of 2. That automatically indicates that it's going to be some form of a parabola. That's
Right.
the easiest way to identify, which brings us to the last one. Take a look at D. So Monica, I'm with you. The x has a power of 1, but over the entire function, there is a square root, something you've never seen before. What would you venture as your guess?
Neither.
Neither. It's true. You will learn later on a square root is actually the same as something. So x to the power of, or square root is actually x to the power of half. It's a completely different exponent. You don't understand why, but for now, just know that this is what it actually means. And that's why it's neither. X to the power of 1 is linear, x to the power of 2 is quadratic, and neither is not 1 or 2. Okay? Visually speaking, Hazel, E, what kind of relation is this? Going once. Yep.
Linear.
Perfect. Just, I mean, a straight line. Not going to go any further. Claire, F.
Is it quadratic?
Close. This part looks quadratic, doesn't it? But to be a true quadratic, in other words, a parabola, it has to be mirrored image. This funky one actually continues on and on and on and basically hits a flat line. In other words, it's something you've never seen before. It's actually a neither. But I added this in for all of you because this is something you're going to see sometime this year. It's called an exponential. You might have heard that word before. Imagine this is time and the y-axis is money. Would you be happy about this or would you be sad about this? The word exponential is very, very common in the world of finance because this is what you want your retirement to be like. All right, keep that in mind. Last one, G. Maddie Wong?
Is it neither?
It's neither, correct. What gave it away?
There's the exponent like would have a power of 1, but it's not like one straight line because there's 2 of them.
Right. So this looks like a straight line, so you think it's linear, but you know that y equals mx plus b should be just a regular straight line. This is something completely different. Okay, and you'll actually see this again this year as well. It's called an absolute value function. But don't worry, don't be scared. I'm going to move on. Clear all this. Okay, I'm just going to do number 2 for now. I'm not going to do number 3 because you might get a chance to, you can try it yourself, really. 125. Let's do this. Consider the following. We have y equals negative 2x plus 1. Try to graph it. What is the slope? What's the y-intercept? And if the value is this and if the value is that, we'll get to that in a second. I'm going to refresh your memory. So if you weren't quite sure how to do it, or if you did do it, see if it works with me. I know this is y equals mx plus b. I know that m is a -2. I know that b is a +1. And these will translate into some kind of visual graph. But first, let's answer this. What is the slope? If you remember from last year, you know that m is the symbol for slope, or the rate of change, and that is -2. And the letter b was used as the y-intercept, and that is +1. What does the slope of -2 mean? It means the rise over run is basically 2 down and +1 to the right. What does a y-intercept of +1 mean? It means that there is a ordered pair or a point of 0 and the letter b that exists on this graph. So with these two pieces of information, we can graph our line. An easy way to think about it is the y-intercept is sort of like our starting point, and the slope is how we move from the starting point. So let's do this. Rise over run is 2 down, 1, 2, and 1 to the positive direction. 2 in the negative direction, and 1 in the positive direction, so on and so forth. And if I can go down this way, I can also say that it can also be a +2 with a -1, right? That's still a slope of -2. So my rise is 2 positive direction and 1 in the negative direction. 2 positive direction, 1 in the negative direction. You don't have to do that many points, but you will see that once you draw 1 or 2 points, it actually does create a straight line, and that's all we need. I'll give you 10 seconds. Any questions? If you want to make a note for yourself, because this is still a refresher, tell yourself this is -2 and +1. You can also tell yourself that this is +2 and -1. They both give a slope of -2. Let's move on. For y equals -2x plus 1, if the x value is -3, what's the ordered pair? That's a funky way of saying substitute x with -3. And if you solve it, -2 times -3 is +6, plus 1 is a 7. There is -3, 7, because that's an x, that's the y on the graph. Is that true? -3 as my x. 1, 2, 3, 4, 5, 6, 7. It makes sense. I would say that's pretty accurate. If the y value of a point on this line is -6, what is the ordered pair? Well, same thing. If the y value is -6, it's a funky way of saying just substitute y for -6. And comes a little bit of algebra. I ran out of space here, so I'm just gonna do this. I want x all alone, so the +1 has to go. So I'm going to, let's use a different color, subtract 1 from both sides, giving me -7 equals -2x. Now I want x all alone, so I'm going to, let's use a different color, divide both sides by -2, giving me x is equal to a +3.5, -7 over -2. This time, I know I'm just sort of zipping through, but if you want to use a calculator or just want to copy this down on your sheet or even on a piece of paper, you can do so. Does that mean that when x equals 3.5, the y value is going to be -6. Let's test it. 1, 2, 3. If the x value is 3.5, 1, 2, 3, 4, 5, 6, yeah, I would say it will cross -6. So it checks out with our graph. In this same way, question 3 in the next page asks a very similar question, but this time it gives you a graph but doesn't give you the equation. Using number 2 as a reference, I think everyone can try number 3 as homework or whatnot. I'll leave that to you because I want to get to factoring right now. 10 seconds. Any questions?
Do you think you could quickly go over what you did on E again there? I'm a bit confused on that part.
Yeah, absolutely. I might need a little bit of space, so let me clear. You know what? I'm going to do it on the left side, okay? I know I'll use black because it's hard to see. Here's the equation. Can you see this? James?
Yeah, I see that.
Perfect. So it says if the y value is -6, so literally I'm going to replace y with -6. Okay? If this is the case, what's my ordered pair? An ordered pair being, what's my xy? Well, luckily, I already have y, don't I? So when I say, what's my ordered pair, the question is actually asking, what's x? If I want to find x, I need to get x all alone. So this is just basic algebra. I'm going to subtract I'm going to subtract 1 from both sides so that the positive 1 disappears. So -6 minus 1 is -7, and this is -2x. From there, I want x all alone, and what's with x right now? A -2 is being multiplied. So I'm going to divide both sides by -2, because anything divided by itself turns into a 1. So x is all alone. And using your calculator, you get -7 divided by -2. It's going to be a positive 7/2 or 3.5. Bring that back to what we were originally trying to do. If my x value is a -6, my y value, if my y value is a -6, my x value is 3.5.
Okay, that makes sense. Thank you.
Perfect. I'm going to clear, again, whatever I'm recording here, it's going to be on YouTube or something. I'll make it available. So if you miss something, don't worry about it. Just go back on your own time. Clearing. I want to jump and use the next 25 minutes. So here's number 3 that I was talking about. Number 4, substitution elimination. We'll get to it when we need it later. I want to jump to expanding and factoring, especially the factoring because you might have noticed the quiz is live, and it might be nice to brush up on your factoring skills. Okay. All right. Starting off, the entire section first talks about expanding, in other words, multiplying out, or AKA distributive property. And then simplify, which means group-like terms. In its most basic definition. So an easy one, 2 is multiplying with the binomial. This is equal to 2x plus 10. Right? 2 multiplies with x. 2 multiplies with 5. Who was I at? Uh-oh, I think my list reshuffled, so I don't know who I did and did not ask yet. Oh well. Anyways, okay. Let's move on to the next one then. Baby brain, I don't even remember. Marin? Using this as a template, what would you venture the answer to be?
x squared,
Mm-hmm.
2y.
Almost. It'll be 2x 2y.
Oh, right.
Yep. Just as a reminder to everyone, anything that is multiplying to the bracket, literally, it applies to everything. Okay. In the same way, you could probably do this. Okay. Please make sure a is actually a negative, so you multiply both. 3 times 2, 6. A times a squared. 3 times -4, -12. A isn't multiplying with anything else other than the 12. Negative, it's actually a -1. -1 times 2 is -2. And a times a is a squared. -1 times 3 is -3. A times b is ab. Ta-da! Are there any like terms? Ooh, yes, there is. That would be 4a squared minus 12a minus 3ab. Simple as that. I'm hoping that you remember how to FOIL. I'm going to leave this hard one for you to try and get wrong, and also ask you to take the time to reach out and ask me. That's also sort of, I'll be your practice of going through the motions of taking initiative, okay? When you have two binomials, it's not just one little term, but the term itself is actually a binomial. The same thing applies. This entire bracket has to be distributed to the first term here, and the entire bracket has to be distributed and multiplied to the next term there. So the acronym that someone developed is, what you do is you take the first term and you take turns sort of multiplying it out. And then you take the second term and you multiply it all out. I actually personally don't like the term FOIL, because FOIL falls apart when it's not binomial with the binomial. Like, what if I have x plus 2 and then x plus y plus z? It still happens, right? But we can't call it FOIL anymore because there's way too many numbers to multiply. The acronym doesn't work. But in any case, let's continue on. If we were to multiply this out, x times 2x is 2x squared. X times -4 is -4x. 3 times 2x is x squared. And then minus 12. Grouping like terms. There it is. Okay. 10 seconds. Any questions about expanding? No? Okay, let's move on to factoring. I have 20 minutes. I can do this. I can do this. Clearing. Common factoring. So factoring in itself means all of this. If I say, go ahead and factor, you need to be able to look at a question and be able to identify what will help you break apart polynomials into smaller numbers that multiply with each other. Okay, that's on you. How do you develop that skill? It's essentially developing an eye through practice. Unless you're a computer, like supercomputer, no one's gonna be able to look at it and be like, this is a solution. You gotta look at it and be like, from my previous practices, this looks awfully similar. I'm gonna try it this way. And because there is an element of trial and error, a lot of people don't like math. Not guess and check, but try a solution or try a method and see if it works or not. A lot of people don't appreciate math. Okay. Sorry, Alex, I poorly missed that chat. I'm going to refer to it now. Yes, only x to the power of 1 over 2 is neither I'm a little confused of that one. But you asked me 2x2 minus 8. Oh, for the common factoring one. I see. So let's get to the x to the power of half later. Okay. Let's cover this common factoring one. It's a good attempt, but you're gonna have to take a look at what is available from both terms. So what is common, hence the word. I see a 4, I see a 16, and from the multiplication tables that I memorized when I was in grade 2, I know that 4 and 16 are part of the same multiplication table. I can divide out a 4 safely from both without bringing out decimals or any kind of funky business. So 4x divided by 4 is just x, and negative 16 divided by 4 is negative 4. And that would be my answer. Okay, you could divide out a 2, but you wouldn't be done. Take a look. If I divide out a 2, this would be what? 4 divided by 2 is 2x, and negative 16 divided by 2 is 8. 2 and 8 still have something in common that I can divide out. So you'd have to keep going. So it is in your best interest to try to find the biggest number to divide out in the first go. If not, just keep going. In the same way, Alex, just because you're brave enough to write it on chat, could you try identify what is common between 3m squared and the 6m? No? I'm not sure if you're actually trying to chat or something because I can't see who's active and who's not. Excellent, that's right on. In chat, he wrote 3 can be divided out, and there is 1m in common. So 3 divided by 3 is a 1, which I'm not going to write. M squared divided by m is a single m. 6 divided by 3 is a 2, and m divided by m is a 1, which I'm not going to write because 2 times 1 is just 2. There you go. With that same idea, you can apply it to here. What is common between all three? I'll leave that to all of you to try. Let's move on to group factoring. Sometimes, just because a teacher is really, really not nice, okay, they will give you 4 terms. And that is very different from trinomial polynomials that you've done before. So the question is, what the heck? How do you do it? One solution you might try to attempt to see if it helps is called group factoring. Literally, group the first 2 terms and the last 2 terms into like separate dimensions, okay, separate worlds. What is common between the first 2 terms? X. So factor that out. And what is common between the second 2 terms or the last 2 terms? Positive 5. Please note that I said positive 5 and not negative 5. There's a reason, because sometimes you can divide out a negative. Positive 5, and that would be x minus 6. And when you do that, sometimes you're lucky enough to notice that the 2 brackets are common again. So you can divide out an x minus 6 from this term and divide an x minus 6 out of that term. If I take out an x minus 6 from the first term, I'm left with an x. If I take out a x minus 6 from the second term, I am left with the 5. Ta-da! Oops, that meant to be a highlighter. Any questions about what just happened here?
You said sometimes. What's the scenario that maybe it wouldn't be like that?
The only time you can't go further is if the bracket is different. But the whole point is that I have something common between the first one right here and the second one right here. I still have something in common, so I'm going to factor it out. But if you have nothing in common, then you can't factor. Is that cool?
Yeah, thank you.
Okay, perfect. Do you want to take a stab at the next one?
Me?
Yeah.
Sure, I can. So in
Is
the
this Will
first,
talking? Who is this?
this is Josh.
Josh. Why do I
Josh
not
K.
see you highlighting? That's weird. Anyway, whatever. Go ahead.
So in the first one, 6x. See, I wouldn't know here. Could I say that 6x to the power 3 would be common?
Absolutely. This one is literally x, 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 x. And this one is x, x, x. So you can
Okay, so-
divide out 3 x's out of both.
And then what would be left would be x.
Yep.
Minus 6.
Close. The 4. There's 24. Take out the 6.
Oh, minus
or
4.
divide.
Sorry, minus
Yeah.
4. And
That's
then
it. Next
the
one.
Second one would be 5 would be common. So
It's true. You know how before I said notice the plus 5? It's
minus
always
5 would be
nice
common?
to try to leave the x in the bracket positive. So I'm actually going to divide out a negative 5 for you, leaving the x as a positive. And what is 20 divided by a negative 5?
Negative 4.
Right on. And do you see why I sort of did that for you?
Because
I
now the
recommend
two
it?
things are the same.
Yeah, exactly. And so you can
Factor again.
Yeah. There you go. That's it. Explain the last part again. Sure. Helen, did that second example sort of help explain? Sorry, I didn't get to see this chat until just now. Okay, perfect. Yeah, it's just the idea that once you group factor, sometimes coincidentally, not really, the two brackets happen to be common. And so you can divide out again. All right, simple trinomial factoring. This is probably one of the two things you spent so much time with last year. Some of you probably, cried blood, sweat, and tears because factoring sucked so much. But it's such an important skill to have. Simple trinomial factoring means that the coefficient or the coefficient in front of the x squared, the largest term, is a 1. When you have that, you notice that B is a 5, C is a 6. All you have to do is identify what two numbers will multiply to become a 6 and what two numbers will add to become a 5. And these two numbers, of course, have to be identical. No pressure just because it's factoring. Anyone want to venture a guess or have something in mind?
3 and 2.
3 and 2? Absolutely. I don't know who talked that, but thank you. 3 and 2 or 2 and 3, they're both positive. And if they both work, then you know that this trinomial can be factored out into x plus 2, x plus 3, those two numbers. If it's a minus 2, it would be x minus 2. If it's a minus 3, it would be x minus 3, but that's how it works out. And this is why when my daughter grows up, I'm going to get her to memorize the multiplication tables as best as she can because, hey, what two numbers will multiply into a negative 63, but have a difference of 2?
Nine and negative 7.
Something
Or
about 9 and
negative
7.
9
Yeah.
and 7.
When you add it, the larger number has to be negative because when you add it, the result is a negative number. So it's actually going to be a negative 9 with the positive 7. B is going to be x minus 9, x plus 7. That's it. Okay. All right, people, I've got 8 minutes. I'm going to move. Again, even if you don't get a chance to copy this, once today is over, I'm going to truncate this, compress it, and then put it on YouTube in a smaller file, so you should be able to copy any notes you missed, okay? Are you posting the notes? Again, I have to clear my screen every single time I do it, because if I don't, this is what happens. It gets really, really messy. And so I am going to put up this video on YouTube, and you can probably go and find it. I'll try to timestamp it so that you can go straight to the factoring section. Is that okay, Alex? Will you be able to do that instead? Okay, perfect. Sorry about any inconveniences. I mean, it's COVID, right? Otherwise, anything I would have done on hand in class, I usually just staple it in the back of the class so you can take a look at it. Okay, complex trinomial. Complex because it's a little bit more when the a value is not a 1, right? So again, the a value is 2, b value is 5, c value is -7. When you notice that it is not, we do something called decomposition. That's a fancy way of saying break it up and then group factor and then common factor. All the skills that we did in the previous, I guess, 10 minutes just now comes into play. Can you give me, yeah, go multiply a and c. Can you give me two numbers that will multiply into a and c, which is -14, but still add to the middle number 5?
7 and -2.
Perfect. And you got the signs right too. The set, it's a +5, so the larger number has to be positive. Second and -2, second. So this middle number is actually going to decompose or break down into 7x and -2x, because that turns into +5x. From there, I just need space. Let's group factor. Someone who hasn't spoken yet, please just be brave and give it a shot. Can you group factor this for me? Am I gonna have to choose? I'm running out of time, people.
I'll try.
Yeah, go for it.
Okay, it would be 2x outside of the bracket.
Close. 2 and
Oh.
7. What's the common number that I can divide out of 2 and 7?
Oh, both 2 and 7, 14.
No, that you're multiplying. When you're dividing, 2 and 7, you can't divide anything out nicely.
No.
So just leave it.
Oh, okay.
Yeah. So what's common between these two terms?
It would be 2 and 7. Wait, what do you mean?
Oh, well, again, 2 and 7 is, yeah.
I see.
Just the
Okay.
x. Yeah, 2x, just the x. So you leave the 2 and you leave the 7 because they're not nice numbers. You can't, unfortunately.
Okay, I
How about the
understand.
next one? That's a tough one.
So what I'd factor out between 2x and 7.
Yeah.
Nothing. They don't exactly have anything to factor out.
The only thing I would ask is, again, the whole goal is to make the next term, the x term, a positive. So I'm actually going to divide out a -1 so that the -2x becomes a +2x, and the -7 will become a +7.
Okay.
Yeah, I know, it's chew on it a little bit. And there's a reason, because if I do that, remember my goal always to try to make the x value a positive term.
And then the last step then would be, oh, okay. Sorry, you already got to it.
Yeah, sorry. I should have waited. I was just
No,
writing
it's
while
all
you were
right.
talking. So yeah, when you do that, again, just like our previous example, like number 2 or something, there's a common bracket. So you divide that out, leaving x minus 1, and suddenly you've done a complex factoring.
So for complex trinomial factoring, the first step would be group factoring, and then it would be proceed as simple trinomial factoring.
Essentially, the only problem is we have to get to this step. We have to break down the middle term into 7 and -2. How did we do that? We need two numbers that will multiply into a times c, which happens to be -14. And the same two numbers still have to add to a 5, which is the letter b. So that's what makes it complex. See if you can try this, because I have 2 minutes before I want to give you a break. Okay. Wouldn't be, Helen says, wouldn't be -7, so when it multiplies negative, it becomes 1. Yes, perfect. Thank you for reiterating. I'm glad, yeah, I need people like you there. Okay, the last one I want you to do is the example of difference of squares. And then we're going to take our 15-minute break because I've been talking too much and your brain's exploding. Notice, sometimes you will get a situation where it's not a trinomial. X try, right? Does that mean it's impossible? Well, you can try to common factor. Is there anything common between 4 and 81? Not really. Is there anything common between x squared and y squared? Not really. So it might seem like it's a dead end. The last thing I want you to check, at least in the grade 10 level, is are they perfect squares? Is this an example of a squared minus b squared? And lo and behold, it is. What is 4x squared the same as? Well, 2 times 2 is 4, and x times x is x squared. So it's that. 81y squared. What times what is 81? 9. What times what is y squared? Y. So I know this is going to be 2x squared minus 9y squared. Why is that so important? Well, again, I have to give you a break, so I'm not going to go into this. But if you remember, if it's a square minus a square, we can automatically write it as the first term plus the second, the first term minus the second. In other words, 2x plus 9y, 2x minus 9y. For the people who aren't sure how the heck I jumped from here to that automatically, after we go through our next lesson at 11:30 or something, please keep that in mind and reach out. I would love to explain to you, okay? 10 seconds. Any questions?
I have a question.
Yes.
Just for like this class, for our note taking, like do you think it's good enough if we just do the note taking on the worksheets that you assign, or should we be doing like additional, like on graph paper or something?
For the sake of organization, I think just using my paper and adding notes onto it is fine, especially when we, what do you call it? When we are in class and I give you a handout. If I am writing and you're like, oh, that's something helpful. That's like a little trick that will stick in my head. Just put a little asterisk and write it on the side or like on the margin, right? If you have messy writing or your writing is very big, no flack. I have a story behind that. Have a piece of paper just on hand. Know how you study and know what works for you.
Ronnie.
Okay, I'm not going to hold anything against you. I remember when I was a kid, I wrote so small. My father was so upset with me because he's like, the size of your writing is what is it? Is reflective of the size of your heart or something like that. And he forced me to increase the size of my writing. In his defense, my writing was literally like I took a spider, dunked it in ink, and let it run. Like it was so messy and so small. But I don't know. Now it's decent size, and I think there's some merit to it. So I'm not going to hold it against you for having large writing. Okay, do what you can. All right, everyone. It is 10:02 on my Windows, or 10:03 on my Windows clock. I'm going to have us reconvene at 10.
No one talked to my break room, and I'm
Team.
guys like, what's up? I don't care.
Okay, someone's not muted. But anyways, I'm gonna ask you to take a break. Can you come back by 10:20? We're gonna finish another hour and 15. And then if you want to stay for extra help, or if you want to go, we're ending earlier. That's why I'm cutting that 15 minutes of your break short. Okay, go get a break. Go grab your breakfast if you haven't eaten. Go to the washroom, get some water, whatever. Timer starts now. I'll see you at 10:20.
Mr. Kim,
Yes.
I was wondering, do you want us to do the quiz right now? Like quickly?
No.
Or is that for later on?
You can do it anytime you want.
Okay. Is there like a certain time you want it done by?
No, before the end of this quad.
Oh, okay.
If you go to the classroom, when I made a little blurb about in the course introduction, I
Mhm.
made a little blurb about the quiz. It's unlimited attempts, unlimited time.
Okay. Will we have this for like every unit?
I will be. You know what? I'm gonna share with you. This is a great time. Thank you for bringing it up because I am going to share. Do you see this Excel sheet with colors?
Yes.
Okay, this is on our website. This is our tentative schedule for the entire quad. I stayed up all night this past weekend trying to create something so that it'll be a little bit more organized for you. Okay, if you take a look, it says factoring quiz goes live, bracket, unlim at. It means unlimited attempts. This has no due date.
Mhm.
But it's there so that it forces you to sort of brush up without being lazy, because you will need this factoring for all of this stuff. Okay.
Okay.
If you do it or if you don't do it, it's not a big deal. It's a short 5 marks, literally 3 marks, but it's just to motivate you to stay on task, that you don't wait until the weekend or something. That's just too late. So if you don't want to do the quiz and end up doing it like during March break or right before the exam or whatever, all the power to you. Okay?
Okay, thank you.
Yep.
Mr. Kim,
We'll get a break. Yes.
I tried it this morning and it wouldn't let me redo it. Like it just said that I had already done it, and so I just couldn't look at the form again.
Really? Okay. Give me a sec. Thanks for bringing that to my attention. Factoring quiz. Okay, editing, settings. Oh, that's weird. Yeah, it was set to limit to 1 response. That makes no sense. Question order. Okay, try that again, and let me know. Okay?
Okay, thank you.
It should work now. Thanks for letting me. That would have been disastrous. Okay. Oh.
Don't we not have an exam this year?
Honestly, I don't know. I have no. I wish I had answers for you, honestly. But if this year is anything like last, I guess quad or the last two quads, and we're not going to have an exam. Okay, it's going to be credit recovery and whatnot.
Okay,
I
thank
don't think
you.
we have exams just because in first two quads we didn't have it, so it'd be unfair if like some people had like courses in like the first two quads and then didn't have an exam for one.
Hey, I am on your side to that, but for the sake of all the students here, I also want to share with you a story. I do know for a fact, because I teach them tutoring stuff, there are students, number one, either in private school, or number two, who have tutors who want to prepare them properly for the following year. And so they have created fake exams and had them sit down and do them under camera supervision as a mock, also giving them an experience of like the pressure, the time pressure that you get from writing an exam within 2 hours. It's not necessarily just about the material, it's about that experience and being able to manage your time in 2 hours. When you get to university, you have to manage 3 hours. You have to sit there for 3 hours trying to hash through exams in person, right? And so grade 11 and grade 12 is an amazing time to practice that. And so, yeah, I know people who still do it. I know some schools just, some teachers are like, I'm giving you not an exam, but a big test at the end of the year. I don't know, sometimes it seems unfair. Just to make it fair, some teachers will make that exam worth like 1%, but it still forces them to study really hard to summarize the entire year, all the material that they learn. Officially, I don't think there's going to be an exam, but unofficially, you may want to consider or even, not shy away from trying it. And you'll see that there is some pressure. And it's not easy to study an entire year's worth for one test, right? But it is what it is. Everyone's suffering right now. You just do your very best to keep up. Okay? Okay. Wash and break. I'll be right back.